Okay, so let's solve today's Leetcode challenge. Find the power of k-size subarray. So you are given an array of integers num of length L and positive integer k. Power of an array is defined as maximum element if all of its elements are consecutive and sorted in ascending order, minus one otherwise. You need to find the power of all subarrays of nums of size k. So result array would be of size I plus k minus 1, n minus k plus 1. So let's just summarize what we have to find. Consecutive ascending max element out of k size subarray. Let's check how many subarrays are possible in this given example of k size 3. This is of 7 size. So 7 minus 3 plus 1, which is 5. As we can clearly see here. This could be the first, this could be the second, third, fourth, and fifth. These will be all the 5 subarrays possible. Then we will check for the consecutive condition, and if the elements are consecutive, like here 1, 2, 3, automatically they would be in ascending order. So this condition will also get satisfied, and we will put 3 in our result array index 0. So this was the brute force of it. Like we will place an I pointer here, and for every index I, we would calculate the subarray starting from that point I up to k, to when the size of the subarray becomes k, and we will repeat this for all the indices in the middle. So here time complexity would be n cross k, which is not efficient. We can use sliding window concept because the subarray size is fixed of 3 sides. So I will initialize an I pointer here, create this window. After that, I'm seeing that this is the extra work required, which I can eliminate. So now I will move J pointer to here and I pointer to here. This is my window now. And as you can see, nums of J is 1 added to J nums of J minus 1. So this is also continuous. I will initialize a count variable, check the number of consecutive elements. First it would be initialized to 1, then 2, then 3. Then as we saw here that it is continuous, it will be initialized to 4. Again we will increase I and J pointers to here. This would be the answer. 4 as the first number. Now this is our subarray. Again we'll check the condition nums of J is nums of J minus 1 plus 1 or not. Here it is not. So now the contiguous thing is broken. So we will again reset our count to 1 and place minus 1 here for this subarray. Again we push through This is our subarray, which again doesn't satisfy the condition. So -1 again. This would be the last subarray. Same nums of j is not equal to nums of j minus 1 plus 1. It's not continuous. Again, we will have -1 in place of this subarray. So this is how we're going to solve this problem. Let's code it up. N equals to length of nodes, initializing the answer array with -1 and size n minus k plus 1. Because that would be the maximum number of subarrays possible. Count initializing the line, consecutive element. Now I will create a subarray, initial subarray of size k. 8 nines of I minus 1, nums of I is equal to nums of I minus 1 plus 1. I will increment my counter. Else, I would reset counter to 1. Now, if count equals to k, we have found out the result of the zeroth index. Well, we are following our result of answer already. Just nums of k minus 1. Max out of the consecutive. That's what we have to determine. Let's keep it as an example. Reference. Now, as we have created this initial subarray and stored this answer in the zeroth index of answer, let's move the I pointer to the first index and j pointer to k. Now, while j is less than n, if nums of j is equals to nums of j minus 1 plus 1, that means it is consecutive. So increment the counter. If it's not, reset the counter 1. Now checking if Count has become greater than equals to k. Anyway, store that result. So answer number of trees. The answer array is of size n minus k plus 1, and whatever the ith element represents is what the uh, answer pointer would also point. Now increment both the I and j pointers, return answer. Let's run. Okay. Okay. Possessive list. Now let's check the condition. Passing all the initial test cases. Let's hope for the best. Okay, so it has passed. So this was today's LeetCode challenge. Let's meet tomorrow. Bye bye.